Assalamualaikum guys, today we are talking about intervertebral disc. The articulations between the adjacent vertebral bodies are symphyses with inter intervening a fibrocartilaginous disc that act as cushions. Healthy intervertebral disc is an adult account for approximately one-fourth of the height of spine. When the trunk is erect, the differences in the anterior and posterior thickness of the disc produce the lumbar, thoracic, and cervical curves of spine. The intervertebral disc incorporate two functional structures. First one is a thick outer ring composed of fibrous cartilage called the annulus fibrosus. Our annulus surrounds a central gelatinous material known as the nucleus pulposus or nucleus. The annulus consists of about 15 to 25 concentric layers of the coarse collagenous tissues that are bonded together. The collagen fiber of the annulus crisscross virtually at about 30-degree angles to each other, making the structure more sensitive to the rotation strain than to compression and others. The nucleus is a gelatinous structure that makes up 40 to 50% of the volume of the healthy adult human disc. In young healthy disc, the nucleus is approximately 90% water. Now we will talk about the pictures. Here you can see the lamina in the cervical vertebra. Here is the lamina, and the body of the cervical vertebra is detached. The bifid spinous process is above and superiorly, and vertebral foramen superior articulating surface is here at the anterior end, and transfer foramina is there. After that, transverse process is at the end. Then we will talk about the thoracic one. Thoracic has lamina here and pedicles, body, facet that articulate with the rib head, vertebral foramen, superior articulating process, facet that articulate with rib tubercle, and here is transverse process, and here is spinous process. Then we are talking about the lumbar vertebra. Here is lamina and pedicles, body, vertebral foramen, transverse process, superior articulating process, and spinous process. Here are the movement and curvature. Here you can see on cervical spine 45 degree of the movement, and in the form of thoracic you can see 60 degree of the movement, and lumbar you can see 90 degree. The annulus fibrosus, thick fibrocartilaginous ring that forms the exterior of the intervertebral disc. Nucleus pulposus, colloidal gel with a high fluid content, located inside the annulus fibrosus of the intervertebral disc. Here you can see about the hyperextension. Specialized material that chemically attract the water. This extremely high fluid content of the nucleus make it resistant to compression. Mechanically, the annulus act as a colloid spring whose tension hold the vertebral bodies together against the resistance of the nucleus pulposus, and the nucleus pulposus act like a ball bearing composed of an incompressible gel. During the flexion and extension, the vertebral bodies roll over the nucleus while the facet joint guide the movement as shown. Spinal flexion, extension, and movement are available. Stress on the disc is significantly higher with the movements. During daily activities, the movements form the loading of the spine. When disc is loaded, then it tends to simultaneously lose the water and absorb the sodium and potassium until its internal electrolyte concentration is sufficient to prevent the further water loss. When chemical equilibrium is achieved, then internal disk pressure is equal to the external pressure, and all things will be in the form of homeostasis. Thank you so much.